find the area. One is going to be the integration. So today we're going to go over to how to find an antiderivative, which will help set up the integration process. Then next class on Friday, you will learn how to solve the area using the summation of little rectangles. And then the following section after that will be using geometric shapes. And then we'll go into the actual integration, which is the way we'll stick with from now until the end of the year. Okay, so today we are doing just what's called an antiderivative. So when I talk about an antiderivative, it's like I'm going to undo taking the derivative. Does that make sense? Just say yes. So what I'm saying is if f is the antiderivative of f, that means if I have f of x and I take the derivative of f of x, you with me? Then I'm going to try and have this and work my way back there. There should be a problem. There is a problem. There's a huge problem. Can anyone think of what the problem is? Anyone at all? Have any idea what might be a problem? Okay, let's go to like here. I'm going to do this. If I gave you like f of x is equal to 3x squared plus 4x plus 7, what would you tell me the derivative is? 6x plus 4. Do we all agree? If I tell you that f of x is equal to 3x squared plus 4x minus 16, what's the derivative going to equal? 6x plus 4. So my problem is going to be when I have that constant, since when I take the derivative, that constant is 0 and it drops out. My problem is going to be, I'm going to have to, when I take the antiderivative, I am going to always write a plus c to tell myself that there might be a constant there, but I don't know what the constant is. Are you with me? So here we go. So back here, we did that. So if I tell you that f of x is equal to 6x squared plus 4x, what could the antiderivative be? In other words, this is what I get. When I take the derivative, I ended up with the 6x squared plus 4x. I'm asking what I had the step before that. That's a typo. Grayson? 2x cubed plus 2x squared. Plus c. Well, if I put plus c, then it could be plus a negative or plus a positive. Wasn't sure if I pressed record or not. Does everyone understand how he got that?
So it's just going backwards.
It's going backwards. Not bad, right? Not bad? Not bad. So when we did derivatives, we said the change in y with respect to x, we said was f of x, right? So now when I do this, I'm going to have this symbol here, which is the integration symbol. And what that means is it's kind of like I'm solving and I'm multiplying both sides by this d of x to get back to my original equation. And then that's going to give me, and notice that f of x, the f changes to a capital letter plus the c. Sure. So if I ask you to take the derivative of a constant, what do you tell me the derivative of a constant is? 0. So if I'm asking you to take the antiderivative of a constant, what's that going to be? Just the c. I said the constant. I should have said 0. My bad. Now if I take the derivative of some number times x, so like 3x, right, I would get what? 3. So in this case, I would just get k. So when I'm taking the antiderivative of just a number, I'm going to get what? It's a kx plus c. These aren't hard, right? I have this k in front of my function, right? So when I take the derivative of the function, I'm going to get k times the derivative of that function, yes? Now when I go to take the antiderivative of k times the function with this d of x, that means that this all together means the derivative. Are you with me? So I'm going to end up with k f of x. So when you write the integration, you're going to write your formula, and you're always going to have that d of x or d of whatever letter attached to the end. Oh, I forgot my plus c. Well, I'm going to pause and think about that one for a second, because if I have f of x, I'm going to write just to be safe. You know what? When in doubt, write it. I always write it. You can't get points off for writing plus c, but you can get points off for not writing plus c. So you're just going to write plus c on every problem. So if I'm taking the derivative of f of x plus or minus the derivative of f of g of x, you know that you can separate those, right? Yes? Yes. So the antiderivative would be the derivative of the sum or difference of the same. It's the same. I don't know how else to say it. Like you can separate antiderivatives just like you separate derivatives. That's what that's trying to tell you. Okay, moving on. This would be n times x to the n minus 1. Do we agree? If I'm taking the derivative of a number raised to a power, you multiply it by that power, you reduce the power by 1. Do we agree? Now, when I'm taking the antiderivative, I have to work it backwards. So what is that going to look like? Like, I think it'd be better if I put a number in. Can I put a number in? Sure, I can. If I did like x to the third, and you took the derivative, you'd have 3x squared. Do we not agree? Now, when I go to take the antiderivative, I want to end up back here, yes? So I'm going to end up with x to the, I have to add 1 to my power, right? Because I decreased my power to take the derivative, so I'm going to have to add 1 to do the antiderivative. And then I multiply by whatever that power was, so I'm going to have to divide this by whatever that power was. Are you with me? I'm getting there. Dramatic effect, waiting for that. Yes?
Wait, so is there just nothing for the one above it?
Yeah.
No. Because it's just separating.
We'll just never do that.
You will, but you won't even think about them. Like, you'll think.
I know.
It is very confusing. Like, I think it's more confusing with just letters. Yes. So that's being. So like, ignore that mess. So if I have. So this is me already taking the derivative. Yes.
Yeah.
So now I want you to find the antiderivative. So instead of being raised to the third power, what did it originally be raised to? 4. So it was originally raised to the fourth power, yes? And then what do I do with that 7?
Divide it by -1.
Divide it by 4. So I can write it like that, or I can write it like this. And yes, I'm getting there, Grayson. Does that make sense? And if I have something like this where I said,
How do we go backwards?
now we're going backwards, but this is what this is trying to say. This guy right here is I'm going to separate it into 3 parts. Like I could think of it as this, this, this. So I'm going backwards.
So it was
X cubed plus
X cubed 3x squared.
I don't understand this.
Why would we divide it? We can just,
What?
why would we separate them?
Well, you don't have to, but this property is saying that when you go to do one that has more than one term, you can think of it term by term by term. That's what that's saying. Are we happy? Are we having fun yet? So here we go. Find the indefinite integral. And the reason why it's called an indefinite integral is because at this point, we just have this symbol here. We don't have a lower bound. We don't have an upper bound. We're not finding anything in any bounded area. We're just finding the antiderivative. Eventually, we're going to put little numbers there, and we're going to change the problem a little bit. Just a little bit. All right, are you done? No. Should I pause? I'm going to pause. I'm going to pause and take... We can't forget her. All right, so this one, you made it what? Oh, I don't like that. I really don't. Like, I know that this has to be x squared. This is the way I think of it, right? Which means that I used to have a 2, so I'm going to make this 5 over 2, and I can write it like that, or I can write it like this, whatever makes me happy, and then I had that plus c, yes? So this one, the way it's written, is I probably wouldn't do it that way because that's really not helpful. I would probably think of it as x to the negative 4th dx, right? Because I want to rewrite, just like we rewrote before we found the derivative, I'm going to rewrite when I find the antiderivative. Now remember, the power that I'm going to is 1 more. So 1 more than negative 4 is? Negative 3. 1 more than negative 4 is negative 3. So this is going to be x to negative 3, and then I have a coefficient of 1, so what did I have to have before that? Like, to take the derivative, I would have taken negative 3 times something, and I would have gotten 1. What kind of 3? Negative 3. Then here's... Now think about, when you're testing it, ask yourself, what's negative? So if I rewrite this, because I probably shouldn't, if I rewrite this like this, if I take, and I said this is f of x, when you take the derivative, you're going to take negative 3 times negative 1/3, and you're going to get a 1, decrease the power by 1, and you get negative 4, which is what I wanted, right? So if we go back to the very beginning, let's go back here. Remember this guy here? Where I said I'm going to add 1 to the power and then divide by n plus 1? Remember that? Yeah. So if I'm doing it this way on here, then I'm going to add 1 to the power, so this will be x negative 4 plus 1, and then I'm going to divide by negative 4 plus 1. Yes? So then that's how I get the x to negative 3 over negative 3, and then plus my c.
I like, no, I
This is going to take like 5 classes for me to understand.
Huh?
This is going to take me so long to understand. I don't get it.
what are we going to do next class? Yeah.
I'm going to make up another one. Give me a second. Thought, pausing.
We just do the one that's next.
I want to do this one.
Okay.
Again, I don't have a note sheet. I don't even know what's next. It's all going to be a surprise. So you're rewriting this. Please tell me you're rewriting this first, yes?
I'll try.
So I'm rewriting this to x to the 1/2. Now, if I'm following that formula, which you might want to have to start following that formula when you first start, this is going to be raised to 1 power. So I'm going to take 1/2 plus 1. Are you with me? And I'm going to divide it by whatever that exponent is.
So x to 2.
So I get x to the 3/2. And I'm dividing it by 3/2, but I'm not going to leave it by 3/2, am I? I'm going to do 2 over 3, so this is going to be 2/3 x to the 3/2 plus c.
Oh. Will we get points off for you the other way?
What other way?
Just leave it. What if we just added C?
Oh, yeah, you're getting points off all day long. Come on, we're not leaving a fraction within a fraction.
Wait, how did you, what did you do? Multiply or minus seven?
Technically, I multiplied by the reciprocal, so 2 over 3, 2 over 3.
Don't just both out.
Oh, should I randomly make up another one?
Wait, can you go do that?
Huh?
It's gonna cancel too.
The 3.
Dude,
So that's over 1. And I end up with 2/3 times x to the 3 halves.
So if you multiply 3
Why would
times 2/3, you
oh.
get 1, but then you take 1 away.
oh, we count the 2. Okay, no, I see. No, I'm being stupid. Yeah.
That's gonna be a tricky one.
Oh.
Okay, I'm going to freeze the screen. I'm going to pause for a second. So you rewrote this. Are we doing the formula? So I'm doing x to the negative 1/2 plus 1 over negative 1/2 plus 1. So I'm going to get x to the positive 1/2 over 1/2. So multiplied by 2 over 1. So I'm going to end up with 2x to the 1/2 plus c. That's not too bad, is it? Oh, you will. Okay, try that one. You're rewriting it first, correct? X to the positive 1/3. Because it's not in the denominator.
But it's not the same formula every time. It's not.
It is.
So you just add 1 every time.
Add 1 every time. So when I add 1, what do I get? So x to the 4/3 over 4/3. So I'm going to multiply by reciprocal.
3/4 we have to write the f of x when we put the answer.
I care, but
But not that much.
not that much.
Should have a 5-point shoot at so if I'm eighth. Oh.
Okay, try that one.
Oh. Why is it 2?
Huh? You want that one?
Why is it 2?
Oh, you want...
I just wrote that. So you had 3 before. 3 times something is equal to. Once.
Oh, you divided by 3 over 2. 1.5.
No decimals.
3 over 2. It's 3 over times.
If you go step by step by step, and you think of this as that you have 2 and then x, and you're going to add the 2 plus 1, right, over 2 plus 1. Can I just write 3? I'll write 2 plus 1. 2 plus 1. And then here this is understood to be 1, so this will be minus, add 1, so this will be 5x, add 1, so 1 plus 1 over 1 plus 1. I don't think anyone would actually do it this way. And this is technically understood to be x to the 0, so I'm going to add 1, so 4x to the 0 plus 1 over 1. You're not really going to do that, are you? Probably not. But here I'm going to end up with 2x to the 3rd over 3 minus 5x squared over 2 minus 4x plus c. Yes? Okay, the last one. I'm going to want to rewrite before I do. Just like I rewrote to find the derivative, there are like no quotient rules or product rules. So I'm going to think of this as x minus 2 to the 1/2 power. Are you with me? X to the 1/2. So then I'm going to think of this as x over x to the 1/2 minus 2 over x to the 1/2. So then I'm going to think of this as x to the 1/2 minus 2 times x to the negative 1/2. Everyone good? So this is understood to be the 1, so 1 minus 1/2 is 1/2. This is understood to be like x to 0, or so 0 minus 1/2 would be negative 1/2. Now I'm going to do step by step just like I did before. Add 1 to the exponent and divide by that new exponent. Can you want to think of it that way? That's the way I was taught. Am I doing it or are you doing it? Everyone agree? Now, you know how sometimes we said we didn't know what this was, the C? Sometimes we can figure it out if we're given additional information. So, in this one, it says rewriting the integral is key step of finding. So, if I solve the problem with the differential equation and they're giving me a point, once they give me a point, then I can find that constant. Does that make sense? So I'm looking at this. They're telling me the derivative of f of x is equal to 4x. So this is what they're telling me. So now I'm going to find the antiderivative. So the antiderivative would be what? Everyone agree the antiderivative, or f of x, would be 2x squared plus some constant. You with me? Everyone good with that? Now they tell me that f of 0 is 6. So where am I going to put the 0? Where am I going to put the 6? 0's for the x, so this will be 2 times 0 squared. And then this 6 goes on the left. And now I can find c, so 6 ends up being my constant. Which means that I can rewrite my equation as f of x is equal to 2x squared plus 6, because now I can find that c. I just need to have 1 point to find that c, that constant. That was not hard, was it? Usually, yes. Well, yes. Has to be. I don't know if you remember this. A ball is thrown up vertically upward from a height of 6 feet with an initial velocity of 60 feet per second. How high will the ball go? Do I not give you the acceleration? I should give you the acceleration. That's the acceleration is negative 9.8 meters per second. So do you remember the position function? And then the first derivative of the position function was I'm driving my car. My average rate of change would be my what? Speed. So that would be the velocity. Do you remember any of this? Huh? Would I take a picture of my car to speed? I could.
No, you already did it.
Oh, yeah. So when I take the derivative of my velocity, which is the same thing as my second derivative of my position, that's going to be what? Does anyone know? So I'm going down the road 55 miles an hour, but sometimes I speed up and sometimes I slow down. What's that called? Acceleration. So basically, they gave me the second derivative of my position function. Are you with me? And I have to go all the way, and I want to find out I'm going to go back and find my position function based on the acceleration and the information that they gave me. I'm pretending like everyone's shaking their head yes. So I want to find the antiderivative of negative 9.8 of a constant. What is it? If I wrote this, what would you tell me that is? Negative 9.8 x plus c. And this is the, since this was the acceleration and I backed it up one step, so I backed it up to here, that is going to be my velocity. Are you with me? And I put x and I should really put t. Why should I put t? I should, huh? Because it's out of time. So we like to use variables that match what we're talking about, don't we?
So it wouldn't be like it wouldn't be f of x, it'd be f1. Like why is it v1?
Well, v me. Oh. Good catch.
Okay.
No, that. So so do I have anything up there that talks about my velocity?
60 meters.
It's and it says my initial velocity is 60 feet per second. So that means that v of 0, because that would be my initial at time 0, is equal to 60 feet per second. Oh, so I'm going to change this to feet per second. So we're same units. So can I substitute that in so I can find my c? Yes, so I'm going to say v sub 0 is equal to negative 9.8 t. Oh, my bad. Uh, 60. Why am I having such a hard time today? So c is equal to 60. So my velocity function is going to be negative 9.8 t plus 60. Now can I find my position function? How would I find my position function? Do the antiderivative of this. So you're doing, so my position. And what is the antiderivative of that? What's the new variable in t going to be? 2, which means I'm going to have to divide this by 2, yes? Plus 60t plus c, and that's going to be my position function. So cleaning that up a little bit. Do I have anything in the directions that tell me anything about the position of this ball? Upward from a height of 6 feet, so that means that 6 feet is what? The initial height. So when t is, I'm at time 0, I'm at time 0, I'm at 6 feet, so when t is equal to 0, my s of t is equal to 6, yes? So 6 is equal to negative 4.9, 0 squared plus 60. Everyone realizes that if I'm putting in 0, the constant's going to be that number, right? I think Lucas said that a long time ago. That is times 0. So my position function is going to be negative 4.9 t squared plus 60t plus 6. Good. Yes. Hmm? No.
I waited right until we finished.